Hi, welcome back to the XII Sound channel and part 26 in the series all about my Project 12 DIY modular analog synth. In this video we'll be taking a look at the Project 12 Modulator. Yes, the ring modulator. Ring modulators, they've been around, well, since the birth of electronic music, many decades. The basic design is pretty straightforward really. It consists of two audio transformers and a ring of diodes. And the concept for its operation is, on one input you have the signal that you want to modulate, and then on a second input you have a carrier signal. The two signals are multiplied together through the circuit and you get an output which is the sum of the carrier signal and the original signal. If you want to look at the actual operation in a lot more detail, that's a very simple description. If you want to look at it in a lot more detail, there's tons on the net. A simple quick search will take you straight to everything. You can see all the real theory behind it. But that's not really what this channel's about. What this channel's about is using these circuits in electronic music. So how can we use it in electronic music? Okay, well, what I've done, I've taken that basic design and made some slight modifications so that it'll work with the Project 12 synth. My circuit looks like this. So there you can see the two transformers. I've used TY141P transformers. On those transformers, the primary and secondary coils are the same size. So it's a linear response. There's no step up or step down. And then in the middle there's the four diodes. I've used germanium diodes, but you could use silicon diodes like 1N4148 signal diodes. They work just as well. Might be a slight difference in the audio kind of frequencies. The different diodes might give you, it's a bit like on the fuzz pedals, give you a different kind of harmonic content. But anyway, it will work whichever ones you decide to use. Now the additions over and above that basic layout, the first one you will notice is there's a capacitor on both inputs and the output, 1 microfarad capacitor. The reason they're there is just to knock out any DC signals that may be coming through the circuit. You could leave those out and it would still work perfectly well. If you do put the capacitors in, they are non-polarized capacitors. And on my circuit I've used polyester box capacitors and they work fine. The other addition to the circuit, you'll notice there is a voltage divider, a potentiometer acting as a voltage divider on the carrier input. The reason for this is that I will be working with a range of signal levels that I want to put into the input, and having the ability to back off the carrier signal so that it doesn't swamp out the input signal can be quite useful. So that's all that's there for. And it's a passive circuit, doesn't require any power supply. So even with my additions, it's still a very simple circuit. I've put it on a strip board and the strip board looks like this. You may need to shuffle around the transformers depending on what the pin spacing is on the ones that you use. But other than that, the general layout works quite well. The schematic and the strip board layout, I will put, well, they're already in my Dropbox file and the link to that is down in the description. And when I built it, on the back of the panel it looks like this. So it fits quite nicely into one of my standard Project 12 panels. And then the front of the panel looks like this. So you've got the carrier input and the level control at the top there, and then down at the bottom you've got the input and the output, and that's it. It really is that simple. So what does it sound like? Well, you've heard a short example with the crazy voice at the start of this video. So what I did there was I put the microphone into the input and then put I think that was a possibly a triangle wave that I put into the carrier. I think it was a triangle wave. The microphone input actually went via my interface module in order to kind of boost the microphone signal to kind of preamp it, and I did have to back off the carrier signal to get the suitable balance. But as you can hear, it worked quite well. And in fact, if you want to have the most famous use of a microphone through a ring modulator, then just check out any Doctor Who episode that has the Daleks in it. That's what the Dalek voice is. It's going through a ring modulator. But that's just one example. What I want to do is, what will it do in a modular synth? Well, I recorded a little clip earlier on where I've got, on the input signal, I've got a saw wave, and on the carrier, I've got a square wave, and I will play around with the frequencies of both, and you can hear what kind of effects we get. So, yeah, let's go and have a listen to that clip. Well, that's just one example of some of the things you can do. You can stick all sorts of signals into the input and the carrier and play around with the frequencies. You get some fantastic sci-fi effect sounds out of this. So if you want to either play Daleks or have some sci-fi sound effects, or just do something unusual with your electronic music, then I've given you the diagram, I've given you the stripboard layout. It's a really simple circuit to build and inexpensive. So yeah, go on, have a go, build your own.
This is the voice of reflection. If there's nothing of interest to challenge our wisdom, we work with